Hey everyone, and welcome to this explainer. Today, we're diving straight into a massive shift in how software is built. We're looking at the evolution from legacy, tightly coupled software builds to the modern, highly modular architecture that powers the platforms you and I use every single day.
Picture this. You're running a huge e-commerce site. It's Black Friday, traffic is absolutely through the roof. And then, boom, a tiny bug in the product reviews section takes down your entire payment gateway. Millions of dollars, just gone. Poof. So why are tech giants abandoning traditional code bases? That nightmare scenario right there is exactly why.
Okay, let's dive into this. Here is how we're going to break it down today. First, the monolithic challenge. Second, microservices architecture. Third, building with Spring Boot. Fourth, scalability and cloud deployment. And finally, we'll wrap up by comparing maintenance efforts. All right, kicking things off with Section 1, the monolithic challenge, or as I like to call it, the all-in-one risk. So, for the longest time, the absolute gold standard for building an app was the monolith. Think of it like a giant, heavily packed suitcase. Everything, your user interface, your payment processing, the user database, your security protocols, it's all bundled together into one massive, tightly coupled program. And honestly, at first glance, it seems super simple. You've got one repository to manage, one app to deploy. Easy, right? Well, as the application grows, this legacy constraint hides a pretty major flaw. And this brilliantly illustrates that fatal flaw, the domino effect. Because a monolith is built and deployed as just one single unit, all its internal pieces are incredibly intertwined. They rely on each other. So if one tiny, practically insignificant feature breaks under heavy pressure, the whole thing comes crashing down. Literally, a memory leak in, say, a profile picture uploader can crash your entire application. Plus, think about the sheer inefficiency of redeploying gigabytes of code just to push a tiny CSS fix. It makes scaling slow and, honestly, super risky. Which brings us nicely to Section 2. Let's move to microservices architecture, the modular solution, and see how this builds a better system. To fix that terrifying domino effect, engineering teams made a huge pivot to microservices. Instead of one massive, tightly coupled block, you chop the application up into small, autonomous services. It's exactly like building a modern ship with separate, watertight compartments. The whole goal here is fault isolation. By completely decoupling the business logic, you create independent safe zones. So you have one service just handling user authentication, a completely different one for the shopping cart, and another for inventory. If the review service suddenly throws a fatal error, the payment microservice doesn't even flinch. It just keeps operating flawlessly.
Moving right along to Section 3, building with Spring Boot. This is our development engine.
Now, you can't just take an axe to an enterprise app and easily chop it into autonomous pieces without the right tools. So the crucial point here is Spring Boot. This is a seriously powerful, open-source Java framework that makes building these independent microservices unbelievably fast. Before tools like this came along, trying to set up the infrastructure for dozens of separate services was a monumental headache of configuration. Spring Boot completely eliminates that friction. It gives you a ready-to-use, production-grade environment right out of the box. The actual process of spinning these up is so remarkably seamless. First, developers isolate some specific business logic, let's say user login. Then, they instantly spin up a brand new, lightweight Spring Boot application dedicated just to that. They configure the service independently, maybe attach its own dedicated database if it needs one, and finally expose it so it can securely communicate with other APIs. It completely empowers teams to build, test, and deploy standalone pieces of a really complex system super rapidly, all without stepping on each other's toes.
Next up, Section 4, scalability and cloud deployment. We are talking targeted growth here. Now, what's really interesting about this slide is how it visualizes traffic management. Imagine a sudden surge in users hitting your search feature. In a classic monolith, to handle that localized load, you actually have to duplicate the entire massive application across multiple servers. You're paying for server space to host the payment gateway and user profiles over and over again, even though only the search feature is actually under pressure. But with microservices, you only scale the exact service getting hit. You just duplicate the search nodes. It's a targeted approach that drastically alters how you manage resources. And this targeted scalability is an absolute game changer for cost efficiency. It makes microservices a match made in heaven for modern cloud infrastructure.
By deploying these isolated services to the cloud, you get this incredible flexibility to dynamically handle thousands of sudden user requests. The cloud can literally spin up new instances of your busy service in seconds, and then, just as importantly, spin them right back down when traffic drops. You're no longer wasting money duplicating an entire massive codebase. You only pay for exactly what you need exactly when you need it.
All right, our final section, number 5, comparing maintenance efforts. It is time for a reality check.
So, as amazing as microservices are, they drastically shift the daily life of an engineering team. Look at the exact trade-off here. With microservices, deployment is a total breeze because you update services entirely independently, and failure impact is securely isolated. But troubleshooting becomes vastly more difficult. In a monolith, if a transaction fails, you trace it through one unified codebase. Simple. In a microservices architecture, a single user action might bounce between 5 totally independent services. Trying to trace that transaction across a complex network to find a bug, well, it can be a true forensic nightmare. And because of all that distributed complexity, the price you pay for development freedom on the front end is rigorous, disciplined automation on the back end. Maintaining microservices requires a highly robust, multi-layered testing strategy. You absolutely need strict unit testing for individual parts, extensive integration testing to make sure these independent services are actually talking to each other correctly, right alongside comprehensive manual and automated testing. Let me tell you, if you don't aggressively monitor this ecosystem, the complexity will quickly spiral out of control.
So, what does this all mean? The final question isn't just about what architecture is objectively better, it's about what your business actually needs. Are you building a simple, predictable tool where a monolith will absolutely thrive? Or are you preparing to scale globally, where failing to adopt microservices and targeted cloud deployment could cost you everything? It's a big decision. Choose wisely.